Hi everybody! Today we're learning about plate tectonic boundaries and the land features that are formed. So on my computer screen here, I have a simulation where I can put in different types of crusts and I can move them. So right now I have two continental crusts and I'm going to move them together. What we're going to see forming, hopefully if I can move my finger, is a mountain range. So this mountain range is forming between these two continental plates as they move together. It's going to be increasing in elevation up into the sky and also down into the mantle. Now what we're going to do is I want to compare that to if I have oceanic crust. So in this one, I'm going to move them together again because that's what I just did. I want to pause it here really quickly and talk about this that's forming right here. This is a trench where one plate is going underneath the other plate. So this trench is actually really, really deep in the ocean if you think of the Mariana Trench. I'm going to keep it going, and I want you to pay attention to what's happening over here. So I see this plate is starting to melt as it enters the mantle, and as it melts, it's going to form these volcanoes. So these volcanoes are forming as this plate melts and the magma rises to the top. I would see the same thing happening if I had oceanic and continental plates. So I'm going to start my simulation. See if I can move my finger out of the way. I have my oceanic plate melting, and it's going to form this volcanic range over here. So the only difference when it's oceanic and oceanic continental is that in ocean it forms an island ring or a kind of islands. On continental, it's going to form this volcanic mountain range. Now what we want to look at, we've looked at the plates going towards each other. We want to look at plates moving away from each other. So I'm going to put on two continental plates. I'm going to make sure that I show my labels, and I'm going to drag the plates apart from one another. And so immediately what we see happening is my continental plates are here, and I have now in the middle oceanic crust. Another thing to pay attention to is right here, I have magma almost coming up and touching the plate. So I have this mantle that is normally very deep under the crust coming up and touching the crust. This is going to happen, let me put in old oceanic crust, the same way. So I have my old oceanic crust is disappearing off the side, and I don't know if you just saw it, but young oceanic crust all of a sudden popped up in the middle. And this is happening because the magma coming up is cooling and becoming new oceanic crust. So what we're going to do is we're going to take some notes. Let me just make sure my angle is okay. On the convergent plate boundaries. So on my continental, so convergent overall means that they're moving towards each other. When I have continental plate boundaries coming towards each other, so if I think about my plates and they're moving towards each other, I end up getting a mountain range in between as the plates go towards each other. If I want to draw that differently, I can draw my arrows coming together and going up. And so the big thing here is I get mountains. Notice I'm not getting volcanoes because the magma is not coming up anywhere in there. When I look at oceanic or oceanic continental, either one of these is going to do the same thing. I'm going to use two colors just so we see. The oceanic plate goes underneath the continental plate. I'm going to draw this again without the arrows. My oceanic plate ends up going underneath the continental plate here, and this area is going to connect, and this forms my trench. Then my plate here is in the mantle, so it's going to start to melt, and it's going to come up to the top, and it's going to form volcanoes. So the two big things I get here are a trench and I get volcanoes. What's interesting about these volcanoes is that they are on the less dense plate. Here, the continental plate is less dense. When we looked at two oceanic plates going together, the old plate is more dense and it sank under the young plate, which is less dense. So my two big things are trenches and volcanoes when it's oceanic or oceanic continental. When we look at divergent plate boundaries, so the big thing here, divergent means going away from each other. In continental, as they went away, magma filled in and it became an oceanic plate. So what we call this, if I were to look at it without water filling in, I would have my plates almost moving apart like this, and I have new floor here. We call this a rift valley. It's different when it's oceanic because as my plates move away from one another, my magma comes up. The magma is less dense than the water, so it floats up where it cools, and it's going to start to form a mini mountain range or a ridge. So we call these mid-ocean ridges because the magma comes up and fills in over the top. So our key takeaways are that at a convergent plate boundary, continental, we get mountains. At oceanic convergent, we get a trench and we get volcanoes. At a divergent plate boundary, we get a rift valley if there's no water there to start. And if there's water there to start, we get a mid-ocean ridge. Let me draw that picture for you. Or a mid-ocean ridge. So these are the big takeaways. At the divergent plate boundaries, we do get some volcanoes, then those volcanoes would be right in the middle. So this is actually going to be like a volcano here because the magma is coming up from the bottom of the earth.